Good evening, ladies and gentlemen. Exactly 6 p.m. So we thought we'll start on time. So welcome to the 168th event of the Chennai International Center. It's been quite a journey, almost about 7 years. And today's subject actually is a very different subject. And honestly, it was an eye opener when this suggestion itself came. How many of you will be really interested to understand 3D printing in the context of building construction? But apparently, a lot of work has done in this space by L&T. So we thought the best way is to showcase this particular subject in front of the CIC audience, and that triggered the choice of the speakers in the context of the choice of the subject. So we have two very distinguished speakers to take us through this, and an equally distinguished moderator, Prakash Challa. Now, Mr. V. Sukumar Hebbar is going to be the lead presenter on the subject. An L&T veteran, he's been there for the past 2 decades now, serving in various capacities. And today he is saddled with the most onerous responsibility of leapfrogging L&T in the entire technology space in the field of construction. In fact, he used a very particular term which was very exciting. I don't want to use that now. He will do it. And his team is obsessed with technology 3D and how to improve the entire process of construction. I am not going through this resume. He is a solid L&T, homegrown L&T product. And he has risen to the position of Executive Vice President. And he is the man of the 3D. Now, alongside him, we have a very distinguished IIT professor, head of the Civil Engineering Department in IIT, Mr. Ravindra Gettu, who will also play a very important role today in articulating his thoughts on this subject. I am told he is the mentor to L&T on this subject. And again, a very distinguished faculty of IIT. And his research has enabled him to produce 500 publications covering various subjects. So it is very difficult to get a combination like this to talk to an audience of Chennai International Center. We have a moderator, our own Prakash Challa, a trustee, founder director of CIC. Generally, the role of a moderator is to maintain law and order situation, but we don't have that problem here because both the speakers are on the same page as far as the subject is concerned. But Prakash will chip in with his own views on how it's going to impact the construction industry and so on and so forth. I'm not taking any more time in my welcome address. There will be 25 to 30 minutes allotted for Q&A after the presentations get over. My only request to the participants who are going to read question is, each question shall not have more than 10 words and each word shall not have more than 5 letters. That's the only request. Beyond that, you can ask any question you want. Over to Prakash Challa to moderate it and take the session forward. Thanks.
Thank you, Anand. Ladies and gentlemen, welcome you all to the Chennai International Center. It gives me immense pleasure that I am sitting amidst two giants. One on the right is Mr. Hebbar. I think you have already heard the explanation about what exactly he is and where he is coming from, which space. So it is like, and on my left hand side is Professor Gettu. Professor Gettu is the one who is a part and parcel of the IIT research team which innovated this particular product of 3D construction technology, printing construction technology. It's like marrying the question of applied chemistry, they say, applied technology. Applied technology, the person sitting right to me is Mr. Hebbar, who is actually implementing whatever has been successfully proven in the IIT Madras. And then, in fact, I had invited Aditya Jain. Aditya Jain is there. Oh, hi. I think probably you should just raise yourself so that at least people get to know. He is the first startup of the IIT Madras who has innovated and started his company called Vatsa. First 3D printed home in India, right? I think a big hand to him, please. Thank you, Aditya, for making it. In fact, at a very, very short notice that he was busy and trying to chase him and finally made him to come down. We thought actually we will have you here, but by the time you responded, I think there was no time. I don't want to take much time on this. See, the intent when we looked at this particular new construction technology, we thought that this is a construction technology which is going to disrupt the industry, construction industry, in a positive manner. So, how does it impact? What is it we are looking at in terms of learning? And I think probably at the end, we have a lot of questions to ask. I myself have some questions, and I'm sure quite a few of the audience have. Sir, I would like to mention to both of you, we have a fairly informed audience. Quite a few of them are structural consultants and some real estate developers as well as architects are also there with us. So probably they will also, and the developers. The intent of the developers is to find out whether it's going to be cost effective in the first intent. And apart from that, we have Dr. Gettu speaking on lean construction as well as on low carbon construction. I think first I would like Dr. Gettu to go ahead with his little presentation or a talk. Then later, this will allocate about 10 minutes to him. And then about 45 minutes, Dr. Hebbar will speak about it. And then we have a Q&A session. That's how the format is. Over to you, Doctor. Yeah. You can speak. You have any presentation also?
I have a presentation.
Oh, okay. Then I think we'll move there. Thank you.
So thank you very much for the invitation. It's a pleasure to be here. So I'm sort of the show opener for Mr. Hebbar. I thought I'll take a few minutes to set the context on why this technology is important for us and the world. In this context, I'd like to introduce a new center of excellence that has been started at IIT a few weeks back. It's called the Center of Excellence on Technologies for Low Carbon and Lean Construction. Low carbon obviously means low carbon footprint, low environmental impact. Lean construction is low on wastage, moving towards zero wastage of all sorts. Money, productivity, time, and material and wastage. So this is our center about IIT. I think you know very much. We are in the neighborhood, and we've, again, our ranking has been #1 in the NIRF. This is our group. So we have a mixed group of people who are experts in construction materials, who look at development of new materials, taking the material into the field, construction management, which looks at processes, quality, time, cost, and safety, and building sciences. So we have quite a mixed group. A lot of young people. Our average age would be about 40. I'm sort of one of the oldest. So we have a lot of young people with a lot of enthusiasm who make this group work. So our mission, we have set for ourselves a mission long term to look at zero carbon, zero waste in construction. We want to reach a state, ideally, where we will not have any carbon impact, carbon footprint, low impact, low environment impact, zero environmental impact, and almost no wastage. Nothing goes out when we are demolishing or when we are reconstructing. We try to put it back into the construction. Now, why is this important? So if you look at the carbon footprint, environmental impact, it is said that 40% of all the environmental impact in terms of carbon footprint comes from construction industry. So it's huge. Just one industry is responsible for 40% of the carbon footprint. Out of that, if we have to break it up, about a fourth is operational. That is your air conditioning, lighting, all that, heating, if you may. But the rest, 74%, is embodied. That is, it lives with you, the building, the bridge, as long as you have it. So our idea is, how can we reduce this? Because this, we can make it more efficient. We can use less lighting, we can use more efficient air conditioning, and so on. We want to reduce this 75% as much as possible, try to make it as zero as possible. For this, we have to take research out to the field. So translation is important, transformation is important, and we have to work on different aspects. Like all of you who are in the field know that it's not just making a new material, but you have to take it out there and make people use it. The architects have to know about it, the administrators, the codes, the specifications, the tenders, all this has to accept. So that's why we are working together on different fronts. The problem is clear. We want to go for zero carbon, zero waste, but we have to go up to policy. So our faculty are there in policy committees and trying to change codes, convincing construction managers, making model specifications and tender documents. And we are focusing on trying to showcase these new technologies. On the other hand, we have a lot of waste in construction, millions of tons. Any country, we talk about millions of tons of waste. All of us know. In Chennai, where does all the waste go? Somebody dumps it somewhere overnight. This is what happens. There is no process, there is no formal way of recycling or reusing. We need a lot of materials also. As we construct more and more, we are going to reach soon, in a decade or couple of decades, 1,000 million tons of cement production. We are at 380 or something like that. We are going to reach 1,000. We need a lot of raw material. With the cement, we'll need also stone and we'll need water and so on. We also have a lot of agriculture waste. So we are thinking, can all this be put together? Can we take waste from one sector, put it into this construction, make sure that anything that is demolished goes back into the construction itself? So we have tried different things, attacking different aspects of the life cycle, starting from the material, looking at supply chain, design, construction. So this is an image of the first 3D printed house that is on our campus. Durability is very, very important. Durability is something we neglect a lot. We look at more of the cost initially, how fast we can construct, and then we walk away. But durability is very important, and we cannot talk about sustainability without talking about durability. Then would come demolition, C&D waste, and so on. So some quick examples, things that we have been doing. We've been looking at how to recycle concrete. So we take concrete. In this case, what we did is we zap it with solar energy. We had a huge dish that would concentrate the heat, and the heat makes the concrete disintegrate. It's easier to separate into aggregates and sand and so on. This movie is not running. Let me see. So how do we separate? How do we segregate? This doesn't work, but this is a robot that we use for segregating the waste because it's always mixed waste. Then we are looking at different type of reinforcement. Instead of steel, which we know corrode, can we look at glass as a reinforcement? And we've also done things in the field. It's not that we are just theoretical people sitting in the lab and thinking up stuff, but we have done, for example, with CMRL, we've gone to CMRL and shown them how the pile caps that have to be dumped anyway are reused in their own construction. We've participated in the Ayodhya temple foundation where a 16-meter depth foundation was done. You can imagine, about 50 feet. The whole temple is on a hole that is 16-meter deep. Because it is silty soil, I can talk about it later, but we had to build it up. Again, low carbon, lot of fly ash used, very low intensity concrete. We've introduced low carbon cement, slag and fly ash in a bridge in Kerala. The Rashtrapati Bhavan is being revamped. There are chajjas which are made out of lime concrete very, very early on, which are all deteriorating. So instead of pulling it apart, we've seen how to rehabilitate it. With Godrej, we've looked at lean project delivery. So all this fits in this sustainability goals. So this is my last slide. I want to show that there is a lot of options we have to work on. So sustainability is just much more than carbon. When we are talking about all the sustainability goals, we have to think of all these things. And construction fits in many, many aspects. Construction is responsible for many aspects that governs sustainability. And we have to think about all this. So that's where we are. And in this list, the new construction technologies or lean construction technology is very, very important. So you will hear from an expert from a team that has done amazing work in our country, and you will see how they've taken it forward and what is the future of this technology. So I'll stop there, and I have the pleasure that Mr. Hebbar continues and will tell us about these technologies. Thank you.
Very good evening to all of you. I think the expectation is very high. Professor Ravindra, Mr. Anand, Mr. Challa, everybody is telling that a lot of expectations are from this forum. I don't know I'll be able to do justice. But one thing I'll sincerely try, most of you must have had a very hectic day, and it is very warm outside and a very cool temperature inside. And I'll try my level best to keep you awake till 7:10. In L&T, we always think ahead of others. I would say we are the trendsetters. If we can't do it, who else can do it? So we challenge ourselves. We challenge ourselves to keep ahead of the market, give solution for the better future. In this context, L&T has come out with various solutions in the construction industry. Just before getting into little more detail, I'll just briefly explain what L&T is about. So I think L&T needs no introduction. If I have to tell about L&T, I think it is taking like coal to Newcastle to this August audience. Just the flow of presentation will be a word or two about L&T, then straight away I'll get into 3DCP and what exactly is 3DCP and how L&T has evolved 3DCP and what all projects we have done. Apart from 3DCP, I thought I will just shortly touch, if time permits, IHMCT, in which we did PPVC under the guidance of Professor Ravindra. In fact, he is our great motivator. And if we are today reach some level in PPVC, all the credit goes to Professor Ravindra. Mission 45, that is actually a project which we did in Bengaluru in 45 days time. 140,000 square feet of built up area, we did it in 45 days for DRDO. So maybe it is not exactly connected with the 3DCP, but it is connected with the partly with the PPVC. So I'll just briefly touch upon. L&T was started in 1938 by two Danish engineers, Hawk Larsen and Soren Tubro, with a very humble beginning in a 10 feet by 10 feet room with 10,000 rupees of investment. And by 1950, it became public limited. And by 2019, it is India's largest EPC, engineering procurement construction company. So L&T is an ocean, so it is very difficult to relate you to this particular context. So I would say L&T has got various verticals. L&T Construction is one major vertical which is giving 65% of the revenue of L&T comes from L&T, and L&T's revenue is almost 180,000 crores, 1,80,000 crores, and maybe 65% of that, that is almost 1,20,000 crores come from L&T Construction, which is headquartered in Chennai. And in L&T Construction, there is a particular division called Buildings and Factories, which focuses on all types of building typologies, and Mr. M.E. Satish heads that division. Buildings Factories has got two divisions. One is named as PAF, Public Buildings, Public Spaces, Airports and Factories, which is headed by my counterpart. And another division is called HRC, Health, Residential and Commercial Spaces, which is headed by me. And I have four business verticals under me. One is called Health, that is hospitals, medical centers, and medicities. Again, we are working with IIT for some new type of medical facility. We are also doing a lot of hospitals across India and also in some of the hospitals outside India. IT and office space buildings and data centers, elite and mass housing, and the fourth division is exactly related to this. That is called B&F Fast. It was born 3 years back when we thought that we should do something unique. We should give solution to the construction industry, how to do projects fast, how to do lean construction, how to do carbon neutrality projects. Then we came out with few ideas. One is called 3DCP, that is 3D concrete technology and printing. Second one is PPVC, prefabricated, pre-finished volumetric construction. Then we also thought of self-sustainable building, which is still in a very primitive stage, but we are doing very close interaction with the central government. Maybe some of the projects when high altitude, where there is no electricity, we have to make the building and run it with its own energy. So still it is in research level, and various other initiatives including steel composite structures. What is our vision? I'm sure most of you are in the construction industry, architects. Just for your information, I'm an architect by profession, but I'm doing business now. Maybe 20 years I did the design, and for the last 15 years I'm doing business. Engineers, structural engineers, and many of you are developers. One of the biggest problems we are facing in the industry is skilled workforce. Very, very difficult to get today carpenters, barbenders, and masons, resulting with very poor quality of work. Uniformity is hardly there. All these things, when we look at it, and just on the other side, if I have to compare my product with a machine made product like a car, you go to the showroom, look at a Toyota car or Hyundai car, see the brochure, see the specifications, and ask for a car. You get the car exactly what is mentioned in the specification, what is available in the showroom. And now you go to a contractor. Architect has designed the drawings, and then he has given the specification, and go to a contractor and ask him to construct. And at the end of the day, you get a building which hardly matches with the specification design which is given in the drawing. And architect is not happy with the contractor, neither the end user. So why not we develop a product which is exactly as same as car in the sense it 100% matches with the specification and the design given by the architect. In other words, I would say it is architect's magic wand. Is it possible? Yes. We have tried our level best and maybe we have reached at least 85 to 90% of it. Huge challenges we have. It is not as simple as mentioned that. Professor Ravindra has given quite a lot information about carbon neutrality and carbon footprint. That today, if I'm right, construction industry is one of the biggest contributor for carbon dioxide in the atmosphere. Everything what we do generates carbon dioxide. Labor come from different places. We run a lot of plant and machinery at site, and every resource is taken out of Mother Earth, bricks, steel, everything. So I think we are the biggest culprits. Shortage of skilled workforce, I already told you. Low productivity and also low quality. Construction material wastage. Many times we produce concrete in the batching plant. By 7 o'clock or 6:30, all the labor want to go home, and a lot of product is still available in the transit mixer. It is dumped somewhere below the ground, and it is not getting paid by the client. Also, at the end of the day, contractor makes the loss. Of course, that is one small wastage. Lot of wastage is there, including formwork material. And at the end of the day, it is time and cost overrun. Hardly there is a project which is completed on time. Say 24 months duration for a project, and most of the time, including in L&T, we find it very difficult to complete the project on time for various reasons. It may not be just because of the construction methodology. It may be because of the changes proposed by the client, or maybe sometimes something material has to come from abroad and logistics is a problem, but there is a time overrun resulting with that cost overrun. So all these challenges, if I have to address, I'm not telling 3D is the only solution, but today to a large extent, I think that is a way forward. So what exactly 3D and how it works? First of all, of course, we all are using AutoCAD drawings. So we prepare the drawings in AutoCAD format. Then this AutoCAD format is fed into the 3D printable machine. So drawing, which is there in 2D or whatever in the form of drawing, is getting fed into the machine, and machine starts printing exactly what is there in the drawing in X, Y, Z, all three coordinates. Layer by layer, actually without supporting the formwork system. So I would say how exactly 3D printing starts. Substructure works, basically we do in situ, unless it is strip footing. Yes, it is possible to do it in 3D, but if it is a raft and huge basement is required or base is required with the structural steel or reinforcement steel, it will not be possible as of now with the 3D printing. But once it comes to the superstructure, entire superstructure can be constructed in 3D printing as far as the wall part is concerned. Roof is concerned, we can go for precast or maybe even structural steel if it is only ground floor structure. And then various other finishing items have to be done as we do it in any other normal building. The girder, the gantry girder, what we have today available in India is approximately 11.5 meter by 11.5 meter by 9.1 meter height we can go. That means at one given point of time, I can approximately construct 1200 square feet of footprint into three floors, because 3 meter if it is a residential building height, into 3 floors means almost 3600 square feet of area we can construct. Suppose I have footprint much more than 1200 square feet. I may have to put one more girder, gantry girder, and one more gantry girder like that. So in one project which we have just now started, we have deployed 3 gantry girders. And that means at one given point of time, I should be able to print 3600 square feet of footprint, maybe 10,500 square feet of floors, G plus 2, we should be able to complete. The only drawback is right now in 3D printing, we can go up to G plus 2. We are not able to go beyond G plus 2 because gantry height is not reachable. 250 millimeter per second is the speed at which the nozzle works, pinhead works. And the thickness of each layer will be approximately 25 mm. And per day, 40 such layers of 25 mm means 1 meter of the height of the wall can be constructed in one day. That means for a building of 3 meter, it hardly takes 3 days to reach the roof level. That is one of the projects which we have completed in Bangalore, whom the photo shows Professor Ravindra at our project site. We did one post office building at Bangalore, also Road, 1,000 square feet post office. In 44 days is the duration given in the contract, and we completed in 43 days. I think instead of me talking, audio visual will be a better.
With 3D concrete printing, the future of Indian housing. As proof of concept, we first 3D concrete printed a single-story building. Then, we 3D concrete printed India's first ground plus one building. Now, we have 3D concrete printed a full-fledged flat. L&T has revolutionized 3D printing technology by engineering a concrete mix with locally available construction material and developed ingenious methods to integrate reinforcement. Specialized concrete is a paradoxical combination of properties that ensures pumpability, flowability, green status, and buildability. Both horizontal and vertical rebar are embedded in the printing. 3D concrete printing has several advantages over conventional construction. We are now ready to build up to 4-storied buildings, mass housing, villas, factories, and more. Anytime, anywhere, fast, made-to-order structures are now a reality. Thanks to our expertise in 3D concrete printing.
So 3D construction and printing has 3 M's: machine, material, and methods. So first of all, machine, we need a 3D concrete gantry girder or robotic arm, whatever it is. It depends on what type of product you are looking for. Then of course, batching plant to create the mix, and concrete pump. And as far as material is concerned, of course, there are various materials like cement, silica, some additives, concrete mixture. Of course, that is a trade secret. So nobody will give you exactly what is the concrete mix we are developing. And then, of course, the methods, how exactly we'll have to do it, how the whole product will come up. So first is the concrete mix. What do we do? Basically, we have to make sure it has got workability, means it has to be somewhere it is little thinner, but not very thin. Somewhere I would say it is like a paste. So it is going through the nozzle. It has to go through the nozzle, so it has to be workable. Free flow should be there. And then it should have some kind of a shape retention. In the sense, we put the first layer, and after that there is some time for it to get some strength, and then after the machine goes one full round, then it comes to the same position. By the time the first layer should have enough strength to take the load of the second layer. So the shape retention is also a very critical aspect we should keep it in mind. And bonding, it should be tender enough to take the, what you call, I would say, some kind of bonding with the next layer. The first layer will happen, after some time the second layer will come. At that time it should be tender enough to take the bonding with the next layer. Of course, buildability. These are the various components: cement, fly ash, of course silica, then crushed sand, 5 mm downsize. This is where actually the cost is slightly going up. If the technology improves and if we can go for 10 mm downsize, then we can further bring down the cost. Chemicals and polypropylene fiber and water. Just like when we do facade structural glazing, after the structural glazing is done, water penetration test is done to make sure that there is no water seepage. In 3D printing also, we do the same kind of water penetration test, because there is layer by layer. In fact, 40 layers for a 1 meter means for a 3 meter height, I'll be having 120 layers. So we have to make sure that every layer is having a complete bonding with the next layer, so there is no water seepage. Gushing, and it is able to take the next one particular example which we are right now doing in Chandigarh for border road organization. See, this is a wonderful project, almost 100,000 square feet of built up area. 55,000 square feet of built up area they are given on precast technology. 45,000 square feet of building they are given on 3D printing technology. And we have to complete it in how many months or how many days?
45 days.
No. Since it is 3D printing, they gave us time approximately 4.5 months. And for the precast, they gave 8 months. And I tell you the story. How exactly we construct substructure? I said if it is a strip footing, we do it in 3D. If it is a raft, we'll be doing it in situ construction. Superstructure will be completely doing it in 3D. Slab, either we can go for precast, hollow core slabs, or even conventional slab, but there is no meaning because the very purpose of going for 3D is going for fast construction. If it is a ground floor structure alone, then we can go for structural steel. The wall will be having void in between. It will be approximately 100 mm, maybe around 40 mm, 40 mm, and in between a gap of 30 mm, something like that. And this gap can be used for two things. One is as a thermal insulation material so that there will not be heat radiation, or when we do a lot of MEP works, the MEP conduiting can be pre-planned and it can be fixed in this void. So horizontal rebar will be tied while doing the 3D printing itself. Verticals we can place it for having getting better strength. We can also use different types of lintels. This is the first model housing we did in our own backyard. It was in Kanchipuram shed. We did this G+1 story residential building. And in the ground floor, we did a precast lintel. In the first floor, we did conventional with the plywood. We did the 3D printing, so it is like any other building. And on the right hand side, what you're seeing is with the GA framework, we did the 3D printing. When we do the MEP works, we can pre-plan it, and while doing the design itself in the 3D in the drawing, if I provide a niche, the printing also takes place in the same way, so that in that niche you can keep all your conduits, and later on you have to do with some kind of a gypsum plastering. Or else in the void, what I said, you can place your conduits. Depending upon what type of product you look for, you have two different types of machine available in the industry. First one is basically meant for small architectural features, like you would like to have a small chair, or you would like to have some kind of a street furniture, or maybe a flower vase. Then it is called off-site printing. That means you will be doing it in some factory. So where you have robotic, a radiant arm. So we'll be using this kind of a small things. Quite a few types are available in the market. But the other one is called gantry type, which will be used basically for on-site, which is meant for construction industry. There we have two types. Basically, the first one is gantry, second one is rail. In the rail, the advantage is it can go instead of 11 meter, span maybe 11, but lengthwise it can go for much larger distance. So as I said, it will be having all X, Y, Z axis. So that is why I said it is arcade is a magic wand. You can have any funny shape and the machine goes in that exactly that shape, and you get what you have imagined. It comes on the paper, on the reality. Our journey, I said around 3-4 years back, we thought that we should get into 3D. So initially we started doing some research in our own laboratory. We started preparing the concrete mix, and when we were sure that okay, this particular concrete mix will work, we took a very humble way, a water bottle, put the paste inside, and by pushing by hand, layer by layer, we thought that we will be able to do it. And we were able to do it. So we got confidence, yes, something is possible. So then we wanted to try in a machine. So in India, those days, we didn't have a 3D printing machine. So we went to Dubai. So had a tie-up with the manufacturer, and in his factory, we gave our concrete mix, and that is how the second one is a small water tank of 1 meter high. We could get it done. So that was the first taste of success, and there was no looking back. So we came back to India, and then we hired a concrete 3D printing machine, and we did first ground floor structure in Kanchipuram. It is a mock house, and we got the confidence further, and then we went for G+1 story structure. So all these things when we did, two people were behind us. As I said, first is IIT. IIT gave us the certificate for the suitability, buildability, and the strength part of it. And second was BMTPC, that is basically Building Materials and Technology Promotion Council of Ministry of Urban and Housing, Government of India. Today, Actually, there is no IS code or NBC which says that this is the way this has to be constructed, and codal conformance is that kind of a part we are still in developing. We are also part, and IIT is also part of this council. We hope we should be able to come out with the codes very shortly. But till the codes are published, this is how we can make it work in the construction industry. Some of the other projects which we have constructed. This is just across our headquarters in Chennai, near Manapakkam, where we are doing up almost 10 million square feet of commercial and residential space. It is walk-to-work concept. And there we have done one model house as a for people to come and see what exactly they see. And this house was constructed with the 3D printing. And the person who constructed is here, Mr. Vadivalaga. Can you just get up? Yeah. He's the one who executed this particular building, and it also came in a Hindu newspaper that time. You can see the interiors as well as the exterior. Generally, what we do is exterior surface. You can see that it will be some kind of a roughness, not unevenness, but roughness. It itself gives you some kind of a texture, and we leave it as it is. So that gives a beauty, and people also would like to know, yeah, this is a 3D building. But when it comes to the interior, it would be better you have some very thin layer of gypsum plaster so that it becomes a little smoother. So somebody wants to have a backrest on the wall, it would be better to have some kind of a smooth surface. This is the one what I said, the 3D printed post office. The top one is a 3D view, but the bottom one is a building exactly as constructed. Yeah, so this is the building. So next one is for at Chayar near Kanchipuram. We did for Grasim cement. For them we did Grasim paints. For them we did a factory. That is a small security and one more check-in office. It is under well, the bottom one. What you're seeing is what we are constructed. So we can get different textures on the surface. So you have to add one shaver while printing itself so that it shaves the rougher part of it so that you can get smooth finish. You don't want smooth finish, but you want some texture. In that blade, you can have different type of cutting, so you get different finishes. So this is one of the finishes. What you see it on the left-hand side is a smooth finish. The next one is a regular finish. The third one is some texture. We try to do it, and then you can do any kind of painting. You get the look of any conventional building also. So what exactly is the advantages and what is the way forward? So when I say that if it is a precast construction, it takes approximately 8.5 months, 8 months, and this takes approximately 4.5 months. That means approximately 40% we can do faster. Uh, it will be much easier, less workforce. Of course, many people will look for what is the cost. I'll come to that a little later. So advantages, first of all, I would say faster construction, much faster. Skilled workforce is not required, so we need engineers and maybe some foremen, but not the skilled workforce at site. Quality, very uniform quality. Architect's magic wand, I already told. And then digital workflow. Whatever is done on AutoCAD drawing, exactly that gets printed at site. Lean construction, very less workforce at site, very less staff, no need of supervisory staff, no need of too many engineers at site. So literally it is lean construction. And of course, the moment there is a lean construction, you can save a lot of carbon dioxide. So there is carbon neutrality also comes in the picture. We at L&T, we have taken some kind of a decision by 2040, we have to become carbon neutral. And by 2035, we have to become net zero. Government of India has announced that by 2070, we have to become carbon neutral. And we have taken it much ahead of that particular schedule, but of course, long way to go. And these are some of the initiatives which we have taken in this regard. Sustainability, and of course, the cost. As of now, today cost is approximately 20-25% costlier. I'm telling like this. Don't talk about the entire project cost. Now, which part of the building is getting substituted by the 3D printing? The substructure is remaining as it is. Assume that substructure remains as it is with conventional. When it comes to the superstructure, the entire masonry wall, plastering goes off and you construct with the 3D wall. And slabs, instead of conventional, I would like to go for precast because that is how the speed will be maintained. And then assume that I will go for G+2 storage structure. That would be the minimum volume of work is required so that the gantry, which is hired, which is approximately 1.5 crore per annum, is a hiring charges. So if I'm hiring it, I should get some volume. Then only it becomes somewhat economical. Then it becomes approximately 20% still higher compared to the cost of these elements. Now, it can become still cheaper. That is what we are working on. If that 5 mm downsize, if I can take it to 10 mm downsize, there will be a huge reduction in cost. And with the speed. Now I'll tell you, if you're looking for a residential house, generally it is not revenue generation. It may be for self-occupation. Then you may like to wait for 2-3 months. You can wait, but think you will be paying that rent in your old house. So if you're getting this house 6 months ahead of schedule, that means you will be saving that much of rent, and that is one of the advantage. But when it comes to commercial building, there is huge advantage. If a developer is getting a building constructed in 12 months, and that same building is getting constructed in 6 months, 6 months for that built up area, today rental may be around 200, 250, 300 rupees depending upon the location. There is a huge revenue generation. His payback to the bank loan, everything becomes 6 months or 8 months ahead of schedule. That is how the volume and this speed helps them to make it more economical. So maybe he can afford to pay a little more to the contractor, isn't it? So the way forward is, I would say we have long way to go. I would say miles to go before we sleep, miles to go before we sleep. We have reached some stage, but 11.5 by 11.5 is not a big size, especially for L&T. It is definitely not a big size. We would like to go for at least 10,000 square feet of footprint, maybe G+7 storage building. That means 70,000, 80,000 square feet. Then it really works. 1,200 square feet into 3 floors, 3,600. Volume is not enough. And really, if you have to, we are talking about carbon neutrality and all those things, with 3,000 square feet, what exactly you can make it? So we need volume. So we have to really go for a much bigger gantry, much higher height, maybe around G+7, 40 meter, we should be able to achieve. It will definitely have a lot of impact. Rest, of course, IS code, we are already on the job. And I said about arcades benefit. Having said that, now I thought I'll just, for a few minutes, I have some time. So, yeah. Uh, PPVC we have done little bit, but if I have to say that we have done, no. I'm humble enough to say we are yet to execute a job fully on PPVC technology. We are in a very primitive stage. Professor Ravindra is guiding us, motivating us, but it will take some more days or some more weeks to make it reality. Maybe next time in this forum I would like to present it, but not today. But yes, we have done PPVC in one part of the building, not as a building as a whole. PPVC is prefabricated, pre-finished volumetric construction. When building has got a lot of modularity, for example, hotel has got say 100 rooms, and in every floor assume that there are 10 rooms, and 10 rooms like that, it is G plus 9-story building, and one room will be constructed completely off-site in factory, fully finished, including wall, tiling, toilet, everything done, and it is put it on a container and brought to the site, and at site it will be lifted by the crane and it is fixed, put into particular location. That is prefabricated, pre-finished volumetric construction. That means overnight, previous day when you go across the road, you will see building below the ground. Next day morning when you come, it is come to G plus 3 floors. It is a miracle. It is happening around the globe, but we are still not reached that, but we are working very seriously on that. Maybe 6 months down the line, it should be a reality. But we have done PPVC pods. So I would like to say something about that. We did a project at Bengaluru, Indiranagar, for DRDO, Defense Research Organization, where we got the project on a tender, design build, EPC. Total project duration is 120 days, out of which 70 days, 75 days, they said you cannot enter the site. So 75 days, you have to do all your preliminary works, design, procurement, logistics, planning, scheduling, and getting everything to the site. And on the 75th day, almost all material should be available at site. And then next 45 days, you have to simply erect like a machine, like a machine. This is what we did. And yes, we did it. I think you will see that today. That is the building we did. 140,000 square feet, if I'm right. Yeah, 130,000 square feet. 30 meter by 60 meter is the footprint. And each floor height is 4.5 meter. We did it in structural steel. Actually, it is a composite structure also. Total time duration, as I said, 120 days. So first, starting date, and then by the 60th day, we have to bring up to third floor 100% structural elements. It is a G plus 6-story building. By 60th day, I have to bring. 60th day, I have to bring up to third floor. By 67th day, up to 5th floor. And by that time, I had to complete all the substructure works. I cannot start with the superstructure, but substructure, because foundation has to be done. And then on the 75th day, 100% elements should be available at site. And from 75th day, we start the work at site. By 90th day, I'll be completing the entire superstructure, and we'll be also installing the MEP works. And by 120th day, testing, commissioning, and handing over. And the project was inaugurated by the Defense Minister, Mr. Rajnath Singh, on the 120th day. That is what we did. 100% modularity. Everything was modular. Imagine even the MEP part was done modular. Entire piping, ducting, cable tray, everything was pre-planned, fixed at factory, like cradle system we brought. And cradle was lifted and fixed onto the structural element before the slab was cast. Generally, we do the slab and everything hung from the slab. Here we went in a different way. First, we fixed the entire MEP part and then this thing. So this is what the way we did. That is a finished look of the building, including finishes. And when we did the facade panel had internal wall system already fixed onto the external. Means glass was on one side, maybe on the internal side it may be veneer, or it may be some kind of a drywall partition, whatever is required, also fixed onto the same panel. So when you fix it, the wall is also done. That is toilet parts. This is exactly the PPVC one part. Means toilet. Actually, the toilet takes a lot of time. We have to do the waterproofing, then we have to do the piping, then we have to do the tiling, and finally we fix all the CP and sanitary fittings. And that takes a lot of time in any project. So what we did was entire toilet was done precast in the factory, in the yard, and every item was fixed onto it. So we had to work out 2-3 things. First, what is the total weight, whether my crane can lift that much of weight. Logistics, how far is that particular yard and how much time it takes to bring that particular thing to the site. Sometimes we have to even cut the trees and it is not in our purview, so we have to inform the BMC and tell them that this particular branch may have to be cut so that the container can move. So we did it with the trial run first day. If these are the places we have to cross, where all we have hurdles, this and all is done in the first 75th day. So on the 75th day, material reached after 1 or 2 branches of tree cut, and we had to bring the thing to site. That is the MEP system. On the right side, what you see is the cradle. Entire thing with the structural steel framework we did, and then it was lifted and fixed onto the structural steel beams, and then MEP works was fixed onto that. We had to bring materials from all over the world, and we had to do a lot of logistics planning. We did it, and we brought the material to site. And that is a logistic plan. I don't want to get into so much of detail. And I think a movie will give you much more information.
Project FCS building of Aeronautical Development Establishment DRDO is launched now on 1st February at 00:00 hours 1 second.
लार्सन एंड डोरफ के सहयोग से डीआरडीओ ने कंस्ट्रक्शन की जो हाइब्रिड टेक्नोलॉजी विकसित की है वह कंस्ट्रक्शन प्रोसेस की प्रोडक्टिविटी में तो बढ़ोतरी करेगा।
Thank you very much. I'm only the face of it. Actually, the entire work is carried out by my team. And I would like to introduce my team. Request Mr. Lakshmi, Mr. Rajkumar, and Gandapani. Mr. Lakshmi Narayan is a concrete technologist. It is his brainchild coming out with the proper concrete mix, which is the toughest job, and it is he who took it from 2019 to 23. Rajkumar Murli is an architect by profession, and he is the architect's magic wand. He creates all these shapes, funny shapes. But he's not just doing 3D building. He's also done that DRDO tower and Chandigarh and all fast initiatives. He's the one who is coming out with the vision and implementing it. Mr. Dandapani is a structural engineer. At the end of the day, structural stability for fast is very important because we cannot compromise on the safety. So Dandapani is supporting us with the structural solutions. I have done the easier part of the work, presentation. The next part is the tough job, question and answer session, for which I need my team. Thank you very much.
Thank you, Mr. Hebbar. Aditya is there? I think I would like to give him about 5 minutes. Maybe you can share your thoughts about how you went about your startup and where you are, because I think it's a privilege that you are here. Please come, give your experience.
We start up in 3D.
No, I think there are a couple more now coming up in India. The first one for sure. Yeah. Yeah, thank you so much for giving the opportunity, and sorry for getting back late. Would have loved the opportunity. So, thank you everyone for listening. We started as a company in 2016-17. Of course, we were students in IIT Madras, and right after graduation, we started this company. We received a lot of generous support from the Civil Engineering Department of IIT Madras in helping us guiding us in developing this technology. And we have been developing the entire gamut. As Sir said, there are multiple elements to developing concrete 3D printing. There is the machine, there is the material, there is also what we call the process of, let's say, architectural design, translating it to structural design, getting it on the ground, the printing strategy as we call it. And of course, there is a software that has to be developed. So the software piece is sort of in the background, but it is a very, very critical piece where the user interacts with the 3D printer and ensures that the building is coming out in the right way. So we currently have developed an internal software. We are expanding the mandate of this to actually get more out of the technology and make it easier for the user to understand what is ultimately going to be built. So this is something that we are currently building. We are based out of Chennai. We have a factory in Sholingnallur. We have another facility in Marimalai Nagar. And we currently have a facility in Mumbai as well, and we are expanding to other parts of the country. So we are currently executing projects in Chennai, Bangalore, Mumbai, and elsewhere. And it's a privilege to be on the same podium where L&T presented their technology as well. They have really done a great amount of work. And it's very actually encouraging to see that India as a country is adopting these technologies in a very quick manner. When you start a company, when you speak to investors and others, there is a matrix that they put, and then the highest weightage or discounting is given to what is called regulatory risk. So when we started our work, the regulatory risk element was very, very high. So unfortunately, we lost quite a bit on our valuation because of this regulatory risk. So, but it's actually very encouraging to see that regulators have been pushing this, the mandate to see that these technologies come up. We are actually talking to a lot of firms based out of the US, and they have extremely strict procedures which vary from state to state. But here we have an organization like BMTPC, which is formed by a mandate of the Indian Parliament and works to ensure that technologies are adopted in an accelerated manner, even if the IS codes are not there. And IS codes will take time to be up and running. It is the job of the committee to be conservative. And the encouraging fact is that there is a BIS committee formed. The BIS committee involves IIT Madras, IIT Bombay, L&T, us, several other companies which are working in this. So it's a broad-based committee which has representation from the industries, and good to see, startups also being involved. So there is a lot of encouragement given to new technologies, and I would say after the US, and US is a surprising late entrant, but I would say US is the country which has adopted 3D printing the most at this point in time. There are 4 to 5 large companies which have adopted and scaled up construction 3D printing technology there, although Europe was a leader initially. After US, I would say India is currently sort of in the lead. Of course, we don't know exactly to what extent China is doing certain things. There are a lot of news which we trust, don't trust. So India is actually adopting it in a very rapid pace, and it's very encouraging. And the environment is right. Uh, so the appetite to pay is maybe not as bright, but certainly, I mean, hopefully, moving into the future, we'll have encouraging signs from customers as well to adopt new technologies, value speed, quality, design, as much as people value cost. So that is hopefully something that will happen in the future. But there is an appetite for technology-led construction. There is a push from, of course, the largest procurement agency in the country, which is the Government of India. And hopefully, that will trickle down to the rest of the industry. So thank you for giving me the opportunity.
Thank you, Aditya. That's great to hear about your journey in this particular field. Thank you, Mr. Hebbar, for the detailed presentation what you have given, and Professor Gettu. I have a quick question, a couple of questions on 3D printing construction technology part. You said that maximum height you could reach is only 3 floors. What is the limitations? Why? Is it the structural part of it, or
The gantry part of it actually. The gantry height is, today we are able to reach up to 9.1 meters. But it is not a major hurdle. Maybe some more technology has to be improved on the equipment part of it. And I think we can go to at least another 2-3 floors extra, means around 20 meters if you reach it. At least G+4 story building is possible.
I see.
But with that, the advantage is actually today, if I have to put columns, now whatever I have shown is actually a wall, but I can put reinforcement, and then I can put the same concrete in that particular column, then that can take the load, so we can go beyond G+4 also.
Okay. So the limitation is only from that perspective of the gantry. Because I was doing some research on this, it says that at higher floors, you have wind pressures which have not been to be accounted for.
Beyond
because
60,
the materials which you are using.
beyond 60 meters, then it is called a high-rise building.
Okay.
Then we have to take the wind load and various other factors, but I'm not looking at that height. I said maximum G+7, maximum.
Okay. Thank you. Okay, now the floor is open for question and answers. I think can go ahead and pass on the mic. You can address to the concerned person also, please.
Yeah, good evening, Ravi from Buildcraft. Sir, you have always done these walls as two walls. So is that a external wall requirement, or you cannot do it as a single wall, this printing as on date? I thought there are two walls.
Yeah.
So you can't do an external wall today with a single 100 wall?
Can you just say why it is not possible?
Basically, the void is created for two purposes. One is that we need to introduce the vertical rebar. If there is a vertical rebar, if it is present during the printing, it will obstruct the movement of the printer. So, in order to overcome this issue, we print in two parts: the outer wall as well as the inner wall. Use the cavity to put the vertical rebar and fill that space. That is one reason. Second reason, as Sir mentioned, we use it for placing the MEP conduits. So that becomes it becomes a part of the process itself. There is no need to do a separate chasing activity for placing the MEP conduits. These are two reasons because of which you will go for this kind of a configuration. But we can also print a solid wall. If you want 100, 150, we can go up to 300 millimeter. If it is a solid wall requirement, yes, we can print.
That will again require vertical reinforcements. And it
yes,
will not.
If the vertical reinforcement is needed, then we have to create a void. If there is not needed, the way Sir said, the column as well as the block masonry kind of a concept. If I'm creating micro columns at different locations, then those columns will take care of the vertical reinforcement. And rest of it can be like a block masonry, simple solid wall we can make.
So if it is internal wall and without non-load bearing, so it can be done as a 100 single wall?
Absolutely possible.
Thank you.
Hi, my name is Kalyan from Bentley. I just wanted to understand the reason for that 1000 limit and what happens at the cold joints in the intermediate point. Is there a reason you have to stop at the 1000 thing?
Buildability point of view. So we have a analysis model which we run through based on the early strength gain of the concrete. So based on that, we put a limitation of 1 meter is the safe for buildability because there is no supporting formwork system. The concrete has to gain sufficient strength to take the load of the upper layers. If it goes beyond the limit, the concrete will start buckling. So to overcome that issue, we put a limitation of 1 meter. But yeah. See, we use a SBR, which is a joining agent. We apply on top of the concrete and continue.
Hi, this is Aslam from Kradai. So my question is for the technology, right? So are we, cyber secured in the sense you can't hack and change parameters and the building gets damaged and insurance doesn't cover this? So is it security threat is taken care of this in full fledged? Is that there?
Well, not really. It's like a printer.
No, for the printer, yes.
Yeah.
The command goes,
Yeah.
and if it can be sabotaged,
Yeah.
can the building gets damaged? I mean, the sense
No,
it's
no,
with
it will
wrong
not
materials.
print well. It will not print properly.
Exactly,
You know?
exactly. That's the thing.
Yeah,
So
but you will see it. Nothing will happen later.
the cost
And-
is sunk. So
Yeah.
do we have insurance or coverage for these things? I mean, I'm just asking in the
Yeah.
interest of why adaptability is low. These are the
Yeah.
reasons.
No, I don't think it's anything to do with hacking. I don't think anyone worries about that. It's very similar to your printer. What if your printer doesn't work well or doesn't print properly? No, you get it replaced or you. Yeah. Yeah. Sure.
So we don't give online connection to the printer. It's everything working on offline modes. So there is an encrypted Wi-Fi connection through which the printer can be accessed. So nobody, a hacker, can directly access to the printer. Thereby, what are the concerns expressed by you is taken care.
It's run from a laptop. Basically, it's run from a laptop at the site itself.
Hi, sir. I'm Siva Shanmugam. I'm a structural consultant. I'm worried about the sustainability. If we recycle the material, it's a unique material created by yourself, right? If it is so, is there any risk of reusing these materials? We are already considering reusing aggregates. That's why, is there any risk of reusing these materials after 20 years like that?
Actually, this material is easier to reuse.
Thank you, sir.
Because in general concrete, we have plaster, we have paint and all that stuff. So here you might have paint, but you may not have plaster. And it's easier to separate. One of the biggest problems of recycling is the fact that we don't segregate. At source, we don't segregate. Here it will be much easier to segregate. It will be easier to take the steel out. And the good thing is, you will know the composition. You will know what you are recycling. Right now, when we get mixed waste, we don't know where it came from, what was used. So I believe that this will be easier to recycle.
Hi, my name is Kavita. I'm an architect. I had a question of what is the angle at which you can cantilever out in subsequent layers. So the printer goes kind of as a band, it's going around. But we keep talking about the design possibilities. So each time I'm assuming a little bit of cantilever is possible. So what is the kind of cantilever that?
So in terms of XYZ different planes, X and Y, we can create any kind of a curvature. When it comes to Z, where you want to have a protruding kind of a cantilever, we were tested up to 30 degree, overhanging. Overhanging angle of 30 degree is possible. That is what we tested with the material. But if it is more of an architectural point of view, if we can print in an offsite, in a factory, if it's a smaller elements, we can use a fast setting materials. Thereby, we can even go for a higher overhanging material. As far as the building is concerned, we restrict up to maximum 30 degree of overhanging.
Because the problem will be the subsequent layers. See, imagine I'm a civil engineer, so I try to simplify things. Imagine you're building with toothpaste. You're putting a layer of toothpaste, you're putting one more layer, it's like that, no? You put too much and then it falls, or it'll flatten. Yeah. Generally, it's like that. Like what Lakshminarayan says, they have gone up to 30 degrees. You can slant, but you cannot put a lot of layers because the earlier layer is still fresh. So it will fall off. So you'll have to probably give it time until it hardens. It has to bond well. And probably you'll have to have reinforcement across. So a lot of challenges.
I'm Sujata, also an architect. Just, you did mention that codes are in the making, but wanted to know how earthquake resistant these buildings are. And when the construction is going on, what if there's inclement weather? What happens to the concrete if there's heavy rain all of a sudden?
So in this case that L&T has done in Bangalore, it was checked for earthquake also. So that is why IIT had to come in because there are no codes.
So we had to do almost like first principle type analysis. And Dandapani knows all the story. So we had to look at it and put in enough reinforcement to tie horizontally also. So imagine that you're making a box which is tied such that if it moves as a box and doesn't collapse. So basically, that's as simple as the concept goes. Now, inclement weather, that is certainly a challenge. So they were looking at predicting the weather, if it will rain or not. And once I think it did rain. So you have to stop. Because again, it's just fresh concrete. There is no formwork. You cannot cover unless you build it under a tent. It's challenging. So you have to be careful.
Chitra, I run an education startup. So my question is totally non-technical, but from a skilling point of view, I can see that labor reduction is going to happen, and it's going to take a long time. So when this becomes more ubiquitous, I know that. But how are we thinking, and how is L&T contributing to the skill development corporation in terms of what are the skills that will be required and will be replacing the current labor? And you said engineers, supervisors, that whole layer is going to be reduced. I'm just interested in knowing how the thinking is.
Okay, it is slightly two different subjects. We have our CSTI, that is Construction Skill Training Institute, where we have certified courses for various trades. That is basically today to cater to the present requirement of skilled workforce, maybe carpenters or bar benders or masons or something like that. We are preparing the curriculum. Maybe it will take some more time to bring a new course which will be helping the digital initiatives. So far it is not yet implemented, but we have some more curriculum part we have to cover it up, then we may be implementing.
And if I may add, it is not only skilling of workforce, but also engineers. So like what Lakshminarayan is saying, it is not just conventional brick and mortar. So we have to actually reskill our engineers to think differently, to be able to not just follow the code, but to build without a code. How do you do it? So with L&T, actually, we have a program which has been running for 25 years now, where we call it a user-oriented program, where L&T engineers come to IIT for an MTech. And I think this is the longest running program anywhere in the world between a major construction company and an academic institution. So they get reskilled in many things. In construction management, how to look at the material differently, the construction management and the process differently.
Good evening, sir. I'm Rajesh from Invikara. So I have just interested to know, you're talking about G plus buildings, but below ground, is there a possibility or
basement?
Yes.
So with the current printer, whatever we have, we can go -1 meter. But we are also getting some interesting queries like this. We are working with our partners, whether we can go even -3, -4 kind of a product, so that we are able to address those product requirements also. We are working on it.
Yeah, because gantry height you were mentioning.
Yeah,
so
correct.
If it is below it, then that gantry, that another additional floors can be possible.
So we have to go for some kind of an extension arm through which we are able to go below the ground. So as I mentioned, the current printer can go -1 from the foundation. We are working on some solutions to go beyond that.
Thank you.
Aditya, would you like to speak on this? Are you doing any work on that? Because you are in the manufacturing line yourself. Have you had thoughts or you had any inquiries or something like that?
Yeah. Hello, sir. This is Parivartan from Twasta. Yeah. Building subground, of course, using offsite sort of a thing, we can always take the modules and then construct underground. But as sir rightly suggested, like it's about the extension arm with how much which we can go underground. One thing is the printer itself can start from underground, and then that way we can again shift the printer to above floor and then continue over it. So that way we can get height reaching. But otherwise with the arm, probably up to 1 meter or even up to 3 meter, it can be extended.
Maybe Parivartan, you can also comment on the software side. Since you guys are developing your own software, maybe you can address the issue of hackability and safety, security.
Right. So as sir has told, like it is an offline system where the printer and the machine, it's all localized. So there is no need for it to sort of translate the data through online, but that can be of course secured, and then if you want sort of a centralized area, if 3-4 projects are running simultaneously and I want the control at the uh, at the factory, I can get the feeds, I can get all the data, like say sensor monitoring data and all this, we can get it for analysis. But of course with now with the technology now, a lot of encryption is there and the data can be secured without any problem. Yeah, thank you.
Thank you. Question. Yeah, go ahead, please.
Well, from the normal, ordinary Aam Aadmi point of view, we are staying already in a conventionally built brick and mortar construction for the past so many decades. And we have a terrace which is vacant. So can this technology be now used to make me build the first floor and second floor also, and then use it?
So maybe I think technical subject, because in terms of foundation and all that you have to see. If the foundation
As long as the foundation is good, it should not matter. But I think we have done cases like that. We have to look at it. First, you have to reanalyze if the foundation is strong enough, because you're not going to redo the foundation generally. But even in extreme case, you can think of it. You can put columns on the side and have a slab, and then you can build on it. Can be done. So technically, it's not impossible.
So one question I have on the mixture, which now you're given a certain percentage of the mixture in the concrete, right? Various admixtures are there and various aspects of. So is it a one mix for everything, or depending on the type of the structure you're building, it's different? The admixtures go on changing, or?
No, there are a lot of things. See, first of all, you imagine that you're making the concrete in a very conventional type mixer.
Yes.
It has to flow very easily through your pipe. Has to come out of the nozzle. Immediately after coming out, it has to harden. Correct. This is ideally what you're thinking of. So there is no one mix. Okay. There is no one mix. So that is where the technology comes in. So when they are mixing, there is a concrete technologist always at the site. Okay. Because things vary. Humidity of the sand varies. The fineness of the sand will vary. So you have to know, you have the knowledge to tweak on the go.
Okay.
So it is not something that anybody now can say, okay, I have a printer, I can print. It is not going to work.
Okay. Okay. So finally, at the end of the day, the question of cost is, we are very clear. There are two aspects. One, we feel, is the adaptability. As my friend was telling, that we started with red bricks, and from there we migrated to fly ash, and now we have gone into my one technology, concrete, and now acceptability of some printer coming and building my house. I don't know at the Aam Aadmi whether they will be interested in looking at this. It will be too revolutionary, no doubt. But from a perspective of a complete change, a paradigm shift in the way the housing is going to be constructed, acceptability is a point which we have to think of. Yeah, Vijay.
So one question. One of the things you mentioned is the shortage of skilled labor like barbender. And still, after concrete, steel structures are probably the most important part of a large building. Are not robotics already being used in making these structures so that they can be very strictly compliant to whatever standards and norms you want? Yeah.
So much of mechanization has not happened in the construction industry. Today, initially we were buying steel as it is and then doing it, bar bending at the site. Now we give it to the factory. So it comes cut size completely. The beams are all coming in shape. Everything is coming in format now. So my site management is reduced to a large extent because of the lack of bar bend. But then in terms of small sites, we have the challenge. You have to have a bar bender at site, you have to have, so they are no there. That's a challenge. So there is no robotic, we have not gone into that. See, robotic and whether this technology, all this will happen when volume happens. Unless you have a volume, probably like, AWHO comes out with some 10,000 homes. Yes, this kind of thing works because it's like modular, it just goes on printing everywhere. But for a normal real estate developer, when you look at it from that angle, there is a long way to go, but in a way to go. and that's the future.
I'm Shakti from Prestige Group. Since yeah, it's all about more about the apartments. How about the customization, sir? Post construction, if the end user wants to change anything, how how would it do this? It's like a share wall construction, or it's a load bearing structure.
You want to answer? So it's a load bearing only. No?
It's basically a shear wall kind of a construction.
Yeah.
But once we identify where are the areas you want to do the customization in advance,
No,
if you want to.
post construction, if the end user want to change, if they want to create a door, additional door in between the walls.
It is not generally recommended because we integrate reinforcement all along the structure. It's a complete shear wall which is transferring the load from the roof to the foundation. So being a shear wall, we cannot do such customization. Only thing what we can do, for example, there are areas where the modification may be needed. For example, kitchen. Okay, so those places we can work with the customer in advance and we can keep some flexibility. So those can be on a case-to-case basis, can be worked prior to construction. Once it is constructed, we cannot make any modifications.
How about the services like UG sumps, puddle flange, those kind of an areas?
So concealing can be done as we explained during the presentation. Again, if it is underground more than 1 meter, we cannot print. We have to go for the conventional way of construction.
Thank you.
In any case, whenever you have to modify a building, it is better to consult a structural engineer. Not do it arbitrarily.
People will used to.
I know, but we should stop doing it and not making openings wherever we want.
I want
The
to,
last question,
I'm
yeah.
Bhupalan from Madras University. I want to
Yeah,
know.
can you speak loudly? Mike.
Bhupalan from Madras University. I want to know the durability of the recycled materials which you are using in all the constructions. How do you prove that it is like the traditional material? It withstand, like as comparing to the traditional materials, have you proved that the materials you are using is reliable in the long run?
Yeah, good question. So what we do is, since we cannot wait for many decades before we can put something out, we do accelerated testing. So we are confident that it is as durable as the conventional material.
Brilliant. We started at 6 and look at the time now, 7:30. Bang, we are ending. So this is the 168th event, as I mentioned. And if we really have to rate the 168 events so far, I have attended about 150 or so. In terms of sheer Q&A, this will be rated as one of the best. The quality of questions. So actually, kudos to the audience for a very participative way in which they looked at the technical subject like this. In fact, Prakash and I were discussing, will it be very technical? Will it be very boring? It was absolutely not technical. It was absolutely not boring at all. So we really must thank both Mr. Sukumar Hebbar and Dr. Ravindra Gettu for making it so user-friendly, so easily digestible to an audience like this. And I'm sure this is going to transform the way construction industry is going to operate in the future. But I have a very super Aam Aadmi question. Will the cost of a flat in Mylapore come down? And how much down it will be? Prakash is always increasing the price. He's not reducing it.
It won't reduce. Time value for money is what we discussed, right? So
Anyway,
you're
but-
getting a flat much earlier than 6
But I think the key takeaway is compression of time, bringing more process efficiency, looking at it. Technology is a disruptor, but here it's clearly an enabler. But I must really thank both the speakers. It's been a very encouraging, enlightening session to all of us. And just for the audience information, we have another on 30th June. Again, a slightly technical but a very interesting subject. Dr. Tessie Thomas, former director of Agni 4 Missile. She's the missile woman of India. She's coming from Bangalore to make a presentation on the missile subject. And the subject is at the frontiers of technology, breaking glass ceilings. So that will be on June 30th. July, we have some programs lined up. We will be communicating in due course. Thank you one and all, and thank you speakers. Thank you moderator for this lovely session. Thank you very much.